Moving on to the next problem. The problem says an ISP is granted a block of addresses starting with 190.100.0.0/16, that is total 65,536 addresses. The ISP needs to distribute these addresses to three group of customers as follows. A, the first group has 64 customers, each needs 256 addresses. B, the second group has 128 customers, each needs 128 addresses. C, third group has 128 customers, each needs 64 addresses. Design the sub-blocks and find out how many addresses are still available after allocation. So the problem says the ISP has been granted with 65,536 addresses whose addresses starts with 190.100.0.0/16, the mask. So and ISP need to distribute these addresses to three different groups. And the specialty of this problem is each group has got customers and each customers require a definite amount of addresses. If you take the first group, it has got 64 customers and all the 64 customers need 256 addresses each. So each require 256 addresses. Similarly, the second group has 128 customers and each of these customers require 128 addresses. Similarly, the third group has got 128 customers and each of these customers require 64 addresses. So what you need to calculate is first you need to design this. So we have to split the given block of addresses among these three different groups, and you need to calculate out of 65,536 addresses how many addresses are left vacant. So after distributing, how many addresses will be available, still available for allocation. So we'll go with the problem now. Now the statement says there's a first block or a first group which has got 64 customers and each require 256 addresses. So the first address is 190.100.0.0/16. Since we are dividing into subgroup, let us find out what is a subnet mask of that particular group. That is first group. So according to the problem, it says each require 256 addresses. So the mask can be calculated or found out by the equation n1 is equal to 32 minus log 56 to the base 2, where 32 is the length of the address and 256 is the number of addresses. So when you calculate this 32 minus log 256 to the base 2, you get it as 24. So it is 24. So this will be the mask in case of first case. So with this, now we'll see for the first group, the first customer will have the address 190.100.0.0/24, that is a new submask. 2, as per the problem, each customer requires 256 addresses. So it is from 190.100.0.0/24 to 190.100.0.255. So from 0 till 255, total 256 addresses for the first customer. Similarly, for the second customer, the address will be, the beginning address will be the next address of this. So that is 190.100.6. This is 255 is the maximum. So next what we'll do is we'll vary this particular bit. So this will become 1, this will be 0. So 1 198.0/24 to, once again, even this second customer require 256 addresses. So once again, so it is 24 to 190.100.256/24. So 0 to 255, so it is total 256 addresses, and it goes on for the third customer. Once again, so this is 255 it has reached. So for the next customer it will be 190.100.20/24 to 190.100.2/255/24, and it goes on. There are total 64 customers. So the 64th customer will have the address 190.100.63.0/24 to 190.100.63.255/24. So we started with 0 here, it goes up to 63. So total 64 customers. So this is for the first group. Now we'll go for the second group. In the second case or the second group, we have total 128 customers, and each requires 128 addresses. So once again, we need to calculate the subnet mask for it. So subnet mask, as I said, is calculated by using this formula. So n1 is equal to 32 minus log 128 base 2. So here we require 128 addresses. So this will become 128. So 32 minus log 28 base 2 will be equal to 25. So 25 will be the mask, that is the sub mask in this case. So the same way how we calculated, the first customer address will be 190.100.64.0/25. If you remember, in the last case, that is in the first group, the last address was given as 190.100.0/24 to 190.100.63.255/25. So this will be the next immediate address which has been allocated to this particular group. So it is 190.100.64.0/25 to, so total it requires how many addresses? Total 128 addresses. So to 190.100.64.127. You can see here this is 0, this is 127. So 64.0, 64.1, so on up to 64.127. So total 128 address which has been allocated to the first customer. Similarly, for the second customer, the continuation of the first one. So it is 190.100.64.128. So here it is ended with 127. So it will become 128/25 to 190.100.64.255. So 128 to 255. Once again, total 128 addresses. So /25, this is for the second customer. Similarly, there are 128 customers. So it is 190.100.127.128/25 to, it will go up to 190.100.127.255/25. So this is for the 128 customer allocating this 128 addresses. So the last address here it is 190.100.127.255/25. So the next immediate address will be allocated for the third group. So we'll move on to the third group now. For the third group, it says it has got 128 customers and each requires 64 addresses. So once again, let us calculate the submask. So submask, we'll get it as 32 minus log 64 because 64 addresses are there. So 32 minus log 64 to the base 2 will give us 26. So 26 will be the submask for the third group. So here the first address for the first customer, it will be 190.100 190.128.0/26. If you remember the previous case, the last address was 190.100.127.255. So the next address is 190.100.128.02. How many addresses is required? 64. So it is 190.100.128.63/26. So from 0 till 63, total 64 addresses allocated for the first customer of the third group. Similarly, for the second group or the second customer, it is 190.100.128.64. So this is 63. So this will be 64/26 to 64 to 127. So you have to add 64 for that. So it will be 127. So 190.100.64.127/26. Similarly, when we go for the 128th customer, we will get it as 190.100.159.192/26 to 190.100.159.255. That is 192 plus 64 addresses, which will be 255/26. So this is how we are calculated or we allocated the addresses for each of this group. Now what is the next question asked in this problem is to calculate how many addresses are vacant. So even after allocating the addresses to three different groups, how many addresses will be left unutilized? So let us see how many addresses are still pending. Now let us calculate how many addresses have been allocated. So for the first customer or the first group, it is 64 customers. So number of addresses for each customer, it is 256. In the second group, it is 128 customers and each customer required 128 addresses. And the third case, there is 128 customers and each require 64 addresses. So the total allocated addresses will be equal to, or it is given by 64 into 256, that is in the case 1, that is in the first group. Second group, it is 128 into 128, and in the third case it is, or the third group, it is 128 into 64. So it is 64 into 256 plus 128 into 128 plus 128 into 64. So which will be equal to 40,960. So this is what we get after the number of allocated address. So the question asked is how many addresses are still available after allocation. So out of 65,536, 40,960 are allocated. So the remaining is we have to subtract it. So when we subtract it, we'll get 24,576. So these many addresses are still available even after allocating each group with a required number of addresses. So this is the one where the each allocation for group A, group B, group C has been shown, and the addresses which is still available, that is from 190.100.160.0 to 190.100.255.255. So these many addresses, that is 24,576 addresses are still available for allocation. Hope you got it. So whenever the allocation has come, so first you have to allocate according to, by calculating the mask, that is the sub mask, then allocate to each of the group, then see how many addresses will be left free. So with this, I'll be ending up the IPv4 addressing method used in network layer. So before I wind up, so I'll be giving you two questions. So we'll go to those two questions first. First question is write a note on IPv4 addressing. So I'll just give you a hint here. So in this, you just mention about different methods, that is about classless addressing and classful addressing. Okay, since it is a just a note has been asked, you answer it for maximum of 6 marks. Okay, so the content should be equal to, or it should be written for 6 marks. So this is one question. So second question is, it's a problem, so what we solved just now. So the question says, an ISP is granted with a block of address starting with 100.100.0.0/28, and ISP needs to distribute these addresses to two groups as follows. So group A, which has 32 customers and each requires 512 addresses, and group B, it is 64 customers, each requires 64 addresses. Design the subblock. So the same way how we solved just before this, the same way you need to solve this. There we had three groups, here we have only two groups. So first group 32 customers and each requires 512 addresses, second group with 64 customers with 64 addresses. All the best. Thank you.